Welcome to this month's GKW safety training meeting. This month we are talking about electric safety, safety with electricity. First, we're going to talk about why electric safety is important. We're going to have to explain some basic concepts of electricity, different measurements, different terms. We're going to talk about injuries caused by electric hazards, which include shock, burns, fire, explosions, and electrocution. We're going to talk about how you're exposed to electric hazards at GKW and how to avoid electric hazard. There will be a review and then a quiz. So why are we talking about electric hazards? In 2018, there were 160 fatalities due to electric hazards. This puts electricity as one of the members of OSHA's Fatal Four, which includes falls, electricity, struck by, and being caught between objects. So let's talk about some of these basic concepts of electricity. A key term to understand with electricity is conductors. Certain materials, particularly metals, conduct electricity. Then there are other materials which do not. Those materials are insulators, such as wood, fiberglass, glass, rubber, and plastics. These do not conduct electricity and would protect you from being exposed to electric hazards. Some of the basic terms involved with electricity are voltage, which is measured in volts, power, which is measured in watts, current, which is measured in amps. Then there's resistance. This is what divides the amount of current flowing through an object and changes that current into heat, light, or physical movement. Frequency with alternating current. Water, in its purest form, in distilled water, is a very poor conductor. It does not conduct electricity well. However, when metals, called electrolytes, are dissolved in water, it makes an excellent conductor. Most of the water you will encounter on the job site will have some sort of impurities in it. Electrolytes, metals dissolved in that water will make it an excellent conductor. The different injuries which can be caused by electricity include shock, burns, fire and explosions, and electrocution. Shock is when current takes a path through the body. When you are shocked by electricity, there are 4 criteria which determine the danger which that shock will present to you physically. The first is the amount of current. Current is the amps. Also, the path through the body is very important, the damage caused by the shock. Also, the amount of time that the current will flow through the body is important. And the frequency of the current, if it's alternating current, the hertz of the current will increase the damage caused by the shock. If you come in contact with, at 5,000ths of an amp, you can feel the current of the electricity and it will be disturbing. From 6,000ths to 300ths of an amp, you will have a painful experience. You will also possibly lose control of a muscle. Your muscles will push or pull depending on the type of muscle that it is, and could cause you to grasp and hold on to an electrical wire which is sending the shock through your body. At 5 to 15 hundredths of an amp, extreme pain will be felt, and even the possibility of your breathing stopping. At 1 amp to 4.3 amps, your heart rhythm will be disrupted by the electrical shock. And anything greater than that has the potential of stopping your heartbeat. The next hazard we will discuss just briefly is that of burns. Electricity, when it passes through your skin, will cause burns to your skin. This horrific picture is an example of someone who grabbed an exposed electrical wire, and it was a low voltage electrical burn. If you want to see some horrific pictures of electrical burns, you can do so online. This was the least horrific picture I could find to show someone who had received an electrical burn. And this was at a low voltage, just grabbing a 110 wire, an extension cord with a split in it that exposed the hot wire on the extension cord. This is what would be the result. How are you exposed to fire as a hazard with electrical current? The heat created by electricity can ignite material, including the wire itself, and cause either a fire, or if there's explosives nearby, it could ignite those explosives, or it could cause an explosion of steam. Here's an example of an ignition that happened in my backyard. I had 2 1200-watt halogen tripod work lights in my backyard. Attached to them had a 14-gauge extension cord, which I had replaced one of the ends on. When those 2400 watts were sent to those 2 sets of halogen work lights, the amps which were pulled through there were in excess of 21 amps. 21 amps going through a 14 gauge extension cord with a replacement plug was sufficient to create heat in the resistance of that connection between the two extension cords to start a fire on the two ends of the plug. You can see here on the picture that the metal connectors have burned and that the casing around the replacement plug has also burned. This could have caused a fire in my backyard had somebody not noticed it. This fire and explosions hazard can be encountered with electricity when a high voltage amount of electricity encounters moisture penetration, such as a lightning strike hitting a chimney. This chimney had a small crack in it where moisture was penetrating into the structure of the chimney. You can see here some of the cracks in the mortar cap and in the tuck pointing. That moisture, when the lightning struck the chimney, exploded because it was instantly turned from water into steam, and that steam couldn't escape the chimney structure quick enough, and so it threw these bricks from the chimney feet away from the chimney. If a person was standing near or below this chimney, they would have been injured by the falling debris. This is how explosions could happen with electricity. Electrocution is when an electrical shock is sustained to the body to the point where the current, the resistance, the path through the body, and the duration causes death. Current is the amps of the electricity. Amps is the watts divided by the volts. A 100-watt light bulb, for instance, attached to a 110-volt outlet, is pulling 9/10 of an amp. At 1/10 of an amp, your breathing could be stopped. So less than what it takes to light one light bulb can stop your breathing, and slightly more than what it takes to light that light bulb can interrupt your heartbeat. Resistance is one of the factors to consider in the hazard of electrocution. Resistance is the division of the amps as it passes through certain tissues in your body. That resistance, which is measured in ohms, divides those amps and turns them into heat or light or movement. Then that electricity takes a path through your body. As it spreads out with that resistance, it's going to take the path of least resistance. So if you are wearing metal, such as a necklace, a belt, or a ring, it will pass through those places first. Water with electrolytes in it, sweat being a possible source of electrolytes, would present a possible path through your body. Blood contains iron, which is a metal, and would provide a path through the body. Nerves in your body carry electrical signals and provide, once again, a path through your body. All of these are potential paths through your body which could cause electrocution. As the electric current passes through your body, if it goes through organs such as muscles, your lungs will stop breathing as your lungs are controlled by muscles. Your heart itself is a muscle and will be stopped beating by the current of electricity. Other organs such as your brain could be damaged, the path that the electricity takes through your body. So let's talk about how we are exposed to electrical hazards and how to avoid these electrical hazards. Your primary exposure to electricity at GKW is going to be from power tools, particularly from power cords or tools themselves. You're also going to encounter exposure to electricity from power lines or from lightning. In order to diminish your exposure, we require that you inspect your tools daily. As you drag out your power cord at the beginning of the day, check for frayed spots in the insulation along the power cord. If it is frayed, tag out or dispose of all frayed power cords. If you're working near power lines can be tented. This is an administrative control. It is not your responsibility to tent those power lines. Speak to your supervisor to have those power lines tented. Some engineering controls we can put in place to reduce your exposure to electrical hazards include using insulated tools, using fiberglass ladders, using GFCI interrupters on your power cords, or making sure that you have the proper gauge of power cord for whatever tool that you use. Chart here for what is the appropriate power cord to use for each tool. And remember that your typical hand grinder that we use for tuck pointing is going to draw 10 to 15 amps, so you need to have a power cord which can support and supply those amps safely. The best way to control exposure to electrocution hazards from high voltage power lines is to stay away from them. If you're ever within 20 feet of a high voltage power line, you have entered the danger zone, where you must take precautions to prevent yourself from being electrocuted. Never enter a 10-feet area between yourself and power lines with any tool, boom, ladder, or scaffold. If you are within 5 feet of high voltage power lines, the electricity can actually arc through the air without you even touching it. Never assume that your boom lift is insulated. Only very specific boom lifts are built to be insulated, so assume yours is not. Do not go within 10 feet of power lines. Personal protective equipment is our last line of defense. It is not intended to replace smart actions when it comes to handling electrical hazards. It is intended to prevent accidental exposure. Personal protective equipment items include hard hats, safety shoes, and insulating rubber or leather gloves. A GFCI, a ground fault current interrupter, needs to be equipped to whatever power source you are drawing from. If the power source itself has a GCFI plug on it, then it needs no interruption. But if you are to plug in a power cord into a circuit that does not have a GFCI already built into it, then before you attach your power cord or a splitter, attach a GFCI device. A ground fault current interrupter only protects you from grounding, does not protect you from touching both the hot wire and the neutral wire. If you were to touch both the hot wire and the neutral wire, the electricity would pass through your body as the path of least resistance and cause electrical burns, shocks, explosion, or electrocution. In case something is energized and a hazard is discovered, always leave a path to the circuit breaker. Do not place any obstacles within 3 feet of any circuit breaker. If you're in a lift and the lift itself has become energized by a power line, lower the lift using the upper controls, not the lower control. Use your cell phone to call for help. If you are on the ground and someone is in a lift and it's energized, do not touch the lift. Don't even get within a 10-foot danger zone of the lift. If you are in a lift and it is energized and no one can rescue you, and a fire has started or there's a threat of explosion, if all else fails, do not step from the energized equipment, because stepping from it could create a path from your leg that is attached to the equipment and the leg that is on the ground, and your body would become the path of least resistance for that electricity. This is, once again, only in an all else fails type situation. If you notice that your coworker is energized with an electrical hazard, first, shut off the power. Unplug whatever power source there is. Don't touch the coworker. If you touch the coworker, you yourself could become part of the path of least resistance, and then both of you would be shocked or electrocuted. If you must act to remove the person from the electrical hazard, don't touch them, tackle them, forcing them away from the electrical hazard in such a way that does not create a continual current where your body is continually attached to that electrical current. Call 911 for help when something is energized. Let's review. Electricity can hurt you and can kill you by means of shock, burns, fire, explosions, or electrocution leading to death. Amps, volts, ohms, these all matter. It's not just amps, it's not just volts. All of these matter. The best way to prevent exposure to electrical hazards is to stay away from electrical hazards. 20 feet, you've entered the danger zone. Take preventative action. Do not get within 10 feet of power lines unless those power lines are tented. And at 5 feet, the electricity from power lines can actually jump. Always assume your boom lift is not insulated. Fiberglass ladders are insulated, but metal ladders are not. Electricity will take the path of least resistance as it passes through your body. Nerves, blood vessels are examples of paths of least resistance. Daily inspect your cords, tools, and your job site for electrical hazards. Attach a GFCI before any temporary electrical source, such as a power cord or splitter. Never use scaffolding during a lightning storm. Booms, lifts, or hydromobiles are considered mobile scaffolding. Do not use them during a lightning storm. There will be a quiz following. Please click on the link below, answer the questions to record your attendance to this GKW safety training. Thank you, and let's be safe out there.